Hello, this is John from caveofprogramming.com. In this video we're going to take a look at packages and import statements in Kotlin. Packages are a way of organizing your code, similar to directories in concept. So you can have packages within packages. They are hierarchical entities. For example, we might want to put all the code that deals with a user interface in one package or in sub-packages of it. We might want to put code that deals with data in another separate package and sub-packages of that. By default, if we create a file that doesn't have a package statement at the top, it's in the root package. So right here, my main function is in the default root package. However, we can easily change that just by adding a package statement at the top. So I could write package main, for example, and now this file is in a package called main. Now Java would force this to also be in a folder called main. Kotlin doesn't do that. You can put files wherever you want, irrespective of what package they are in. However, it is recommended that you put files in a directory that corresponds to their package. So for example, if this is in a package called main, it should also be in a subdirectory of the source folder called main. Let's right-click the source folder here and go to new package, and I'll create a package called main, and then I'll just drag main.kt into it. That's refactored my code a bit in a way that's incorrect. I just want this to say package main. So now we've got a file which is in a package called main, and it's also in a folder called main, because when you create new package from the right-click context menu on the source folder, it actually creates directories corresponding to your package. Let's right click it and go to open in Finder, or that will be Explorer on Windows. And here's the source folder. If we go into there, we can see there's a subfolder called main, and in there is my main.kt. Kotlin actually inherits a lot of stuff, including package naming conventions from Java. Package names should be written in lowercase. And in the same way that you would separate the different directories in a file path with slashes, you separate different packages within a directory path using dots. A common convention, if you're going to distribute your code, is that if you own a particular domain name, then you form the root package by reversing the words in the domain name. So for example, I own caveofprogramming.com, so I could right click here on the source folder and go to new package and create a root package called com.caveofprogramming. Now I probably want a sub package for any particular project that I'm going to create here. So let's put this in a further sub package called tutorial. And within tutorial, I would want different packages containing the different files of my program. I've only got one file here, but usually a project will contain lots of files. And we want to group similar files together using packages. In this case, let's just create one sub package called main. Then I'll hit return. And we've created this package here. And I can now drag main.kt into that if I want. When I do that, it's going to ask me if I want to refactor my package statement, and I do, so I'll click OK. And now it's actually refactored it correctly. So I've got a file called main.kt in a package called com.caveofprogramming.tutorial.main. And on my hard drive, it's also going to be in a corresponding hierarchy of directories. Let's take a look. So I'll right click the source folder and go to open in Finder. And there we can see in the source folder, we've got a folder called com. There's also one called main that I created a minute ago. Let's go into com. In there we've got Cave of Programming. In there we've got tutorial. In there is main. And in main is the main.kt file. So this is a good convention to follow if you're going to distribute your code and you have a domain name. Kotlin isn't going to in any way check that you actually own that domain. It's purely a naming convention so that people can look at your code and figure out where it's come from. And it also serves to separate it from other people's code that are going to be in different packages, which might be used together in the same project. However, if you're just working on code yourself on your own machine, this kind of thing is probably overkill. When I'm creating a project, I usually just create single name packages and sub packages within those. So I might, for example, have a package called data or possibly model that contains data handling classes. I might have a package called UI or GUI, graphical user interface, that contains the user interface code. And maybe there's another one called controller that contains more sort of general logic code that connects the data code to the user interface code and so on. But you can basically do whatever makes sense to you. Now here we've got a function called main, and that's in this particular package. There's nothing stopping me creating another function also called main in a different package. The names don't clash as long as they're in different packages. So let's go to this main package, which is now empty, and create a new Kotlin file called main.kt. So it's added package main for me at the top, and actually what I want in there is a function main, and I'm just going to put a print line statement in there. So in my other main I have print line hello. In here let's put print line hi so we can differentiate them. So either of those could be the entry point for my program. Probably the best way to select which one to run is to right click it and go to run, because then you know you're definitely running the right file. Let's just try running this by clicking the run button at the top though. So that says hi, which is fine, and let's open the other main here and try clicking the run button again, and it still says hi, so you can see it's not running the right file. If I right click this other main.kt and go to run on that, so I right click it and use the context menu, it runs the right file, and now you can see it says hello. Now let's create another package here. So I'm going to right click and create a new package which I'm going to call model. So we can imagine that this is going to be a package containing basically data handling classes. In other words, they model my data. I'll right click in that and go to new, what do we want, Kotlin class, and let's create a class called person. We can't go through a whole tutorial without having a person class. Now just so we can see when this is actually constructed, I'm going to give it a secondary constructor here, and in there I'm just going to put print line and we'll put person created. There we go. So we've got person in the model package and we've got a main in this main package here. I'm not going to use this one with a really long package name for the rest of this tutorial, I don't think. Let's go to my main file in main. Now what if I want to create a person in there? So I'm going to write person, and this by itself should be legitimate Kotlin code. I'm not setting a variable equal to it, but you don't necessarily always want to do that when you create an object. Just typing this by itself will create an object and that'll trigger its constructors. And then in the constructors you can put all kinds of code that does all kinds of things, if that is a good idea in the context of your program. But as you can see, it won't let me use person at all. It just says unresolved reference if I hover over it. And the reason is that person is in a different package to this main function here. What I have to do is import it. So the package statement should go at the top, and underneath that we can have import statements. Let's say import, and the package name is model and the class is person. So I'm going to write model.person, and now you can see that it's no longer in red and it works fine. Now let's run it, and to make sure I run the right one, I'm going to right click that and go to run main.kt, and it says person created. So it is successfully creating a person object here. I only need the import statement because the function where I'm using this is in a different package to the package where this actually resides. So if I go to my person class, let's say I have a function in there like fun test maybe. I can happily use person there without any difficulty. There's no red going on there. That's perfectly valid. I don't need an import statement because this test function is in the same package as the person class that it's actually using. I'll go back to main.kt. Another way you can import things from a package is to use star. So if I write import model.star or asterisk, that also works. And that just imports everything from the package, which is often what you want. Sometimes you want to import things from a package. For example, here I might want to import the person class from the model package, but you've already got something with that name that's already been imported maybe from another package. In that case, you can give things their own name when you import them. So here I could say, for example, import model.person as, let's call it per. And then I can refer to it here as per. Let's run it. And you can see it's saying person created, so it still works. Let's go back to person here. Everything in a package by default has what we call public visibility. So you can have lots of things at the top level declared in a package, in a file like this, with a package statement at the top. You can have functions and variables and other things in there, not just classes. So what I'm about to say applies to basically anything you can write as a top level declaration in a package. I could actually declare this with the keyword public, and that means that it's available outside of the file where I declare it. But this is the default anyway, which is why it's in grey and suggests that I should remove it. Another alternative is to declare it private, and this means I can only use it within the same file. So if I look at main now, we've got red underlining going on in connection with person here. We don't get that red underlining here because this is within the same file. But let's create another file within the model package where person lives. So I'm going to right click and go to new Kotlin class file. I'll call this maybe test.kt, and in there I'll delete the class, so you can see that this has been declared by default as being in the model package because of the way I created it by right clicking on the package. And in there let's have some function, I'll just call it hello or something, it doesn't really matter. And we'll try to use person. And you can see that we can't use it. Again, we get a red underlining. So if you declare something private, you can only use it within the file that it's in. You can't even use it in other files in the same package. And that's sometimes useful. Public and private are called visibility modifiers, and we'll talk more about them later. There's also protected, but we can't use that on top level entities in packages, so this will give me an error. But there are other circumstances where you can use it. And there is internal, which restricts the visibility of entities to the module that we're in. But we haven't talked about modules yet in this course, so let's get rid of that and go back to the default, which is public. As long as it's public, then we can use it in the same package and in other packages as long as we import it. Here's a file taken from a kind of Hello World Android application. So this has been automatically generated for me. I created it in Android Studio, and you can see that it does use this naming convention, except that since it's kind of a Hello World example program, the thing that auto-generated it has put com.example.example here. So example.com is a domain name you can use if you happen to need a domain name just to use in some code or something, but it doesn't actually have to be your domain. And it's also called this particular package example within the root package. But let's get rid of that. One other thing that I want to show you in this video is that you can also import Java packages. For example, Swing, which is for creating user interfaces in Java. Let's create a new package here called UI for user interface. And in there I'll right click and create a new file, actually a Kotlin class / file. Let's select file, and I'll call this maybe swing.kt and hit return. So it's added the package UI statement at the top for me. Now rather than type all this out, which would take a while, I'm going to auto-generate some Swing code. And by the way, it is possible that Swing will get removed from Java at some point in the future. So if this no longer works when you're looking at this video, don't panic about it. It doesn't really matter. I just want to show you this as an example of importing Java packages. So I've gone to a browser here and I've searched for Microsoft Copilot. By the time you look at this video, it's possible there may be other, even much better artificial intelligence code assistants, but at the moment this is pretty good. If I click on this, I don't at the moment even have to log in or register. I can just directly generate code here. So let's write something like minimal Swing app in Kotlin, hit return. So it creates a simple little Kotlin app for me. I'm going to click copy on there. I'll go back to IntelliJ IDEA I'll paste that in, making sure to leave the package statement at the top. And you can see I've got a bunch of imports here, and these are importing various Java packages connected to Swing, which is for desktop programming, and you can also use Java FX, which is newer, but Swing remains this incredible mature code base that is still widely used even now, long after Java FX should in theory have replaced it. Let's just run this and see if it actually works. You can see there's already a main declared in there for me. So I'm going to right click swing.kt and go to run. And here we've got a little minimal Swing app with a horribly aligned label on it that says hello Swing and Kotlin. So that's it for this video. Until next time, happy coding.